Very good morning to all. So, indeed, it is a great pleasure for me to share about my research experience at this forum. Before going to the discussion about the specific topic, let me briefly introduce about myself. So, I am ArumugaPrabu. I am working as a professor in the Department of Mechanical Engineering. Plus, I am acting as the dean for our School of Mechanical, Aero, Auto and Civil Engineering from Kalasilingam Academy of Research and Education, which is located at Tamil Nadu, India, and it is uh, one among the topmost universities in our country, deemed universities. And here in our department, we are having the Center for Composite Materials, through which we are doing some quality research in terms of producing natural fiber based innovative products, and in terms of developing materials from waste using the biomass concept. So in such a way that a big group of research team is working towards the development of innovative materials in such a way that my area of specialization is I start working with utilization of waste and how to develop innovative materials from those waste in such a way that will replace the conventional material in various structural applications. So I start with one industrial waste called as red mud, which is produced in huge quantity while doing the manufacture of aluminum. So that one I used as a filler along with the natural fiber and polymer matrix, produce some quality natural fiber based composites in such a way that we are able to develop a innovative material for structural applications. Followed by that, we are focusing on developing materials based on the biomass concept in such a way that various agro waste, various industrial waste we focus that causes a challenging fact based on the environmental aspect. So in such a way that we started working more effectively towards producing those kind of materials from different waste. And this is the brief background about my research area. And as a follow-up, as a advancement of our research, then we started recently focusing on using the machine learning approach in such a way that we are able to analyze the composites and we are able to understand how effectively we are able to produce a optimized composite material. So for that, this will act as a effective tool based on our initial preliminary work. Right now we are also in the preliminary stage, and we are also have a long way to go. We have to dig deep into this studies in such a way that from this we are able to develop a quality optimized parameters which will be more helpful for us to produce, to generate a good ultimate strength composites that focuses on some special parameters. So with this brief note, let me move on to the topic that we are prefer to hear about in the through this session is the machine learning approach on polymers based composites performance. So in general, when you go through the literatures, you are able to understand that there are n number of composite materials based on natural fiber, based on other items, along with the polymers. You are able to refer quality research going on for more than a decade. Now, how to, I mean, and how to understand ourselves that which combination is the right one that possesses ultimately the good required results. So in such a way that this lecture or through this research, our aim is to find the better optimal ones. For example, I will tell you one thing. uh, I am going to develop a composites. Before that, let me move on to my introduction slide. Along with that, I will connect this point, because those who are going to be new first time listening this topic must know what is composites and all those fundamentals. I would like to take another 1 minute. Yeah. So quickly, let me move on to the introduction. As I pointed out, the natural fiber based composites. In general, the composite has two or more materials, and one is called as the reinforcement and another one is called as the matrix. And the reinforcement has different physical chemical properties. In the same way, the matrix has different physical chemical properties. Now combining these two, we are able to obtain the new material which possesses some excellent physical chemical properties, and that will give us some new inferences, some new results based on which we are able to take forward. So this is in general said to be the composite. Now this reinforcement and the matrix, the researchers are using in a very huge quantity, in a huge numbers, in such a way that the more recent scenario focuses on the natural fiber composites, that is the fiber derived from the natural sources, such as from a plant seed, or from a plant leaf, or from a plant stem. Okay, so different plants are there which are available by nature itself, and it is free of cost. So you are going to derive those fibers which has good cellulose and lignin content. Please note this. We can't claim all the plants have good quality fiber. The fiber will be dependent on these two items, the cellulose and the lignins. So whenever a plant, and if you extract the fiber from the stem, from the leaf, or etc., you can claim it as a composite when you ensure yourself that it has a good content of cellulose and lignin. Then only you are able to strongly claim that one as a pure natural fiber that possesses some interesting properties. So we have to carry out the characterization studies in such a way that we are able to understand how much percentage of cellulose is there, how much percentage of lignin is there, in such a way that we will derive that particular fiber derived from so and so plant will be suitable for developing the composites. So this is the fundamental study, the fundamental research that we have to ensure before developing an effective composite materials. So in such a way that now what the researchers are doing is they are focusing on developing the composites material of different weight percentages based on the literatures, or based on their iteration studies, or based on their interest, etc. So now the first material derived from the plant, the fiber, they are going to use it in different weight percentage. They are going to add in different weight percentage. For example, 10 percentage, 20 percentage, 30 percentage, 50 percentage. I will vary my matrix percentage also, that is the polymer. The polymer also I can vary 10, 20, 30, 40, like that. So likewise, not only this weight percentage, the another most important critical factor is the fiber length also. You can choose 1 mm, 2 mm, 3 mm, 5 mm, etc. So these two, the fiber length and the fiber weight percentage, drastically affect the performance of your composite material. So what the researchers did, now the researchers will ultimately focus on these two properties. Another one property is there, I forgot. Just I will give you a spark on that. That is the fiber orientation. How you are going to arrange the fiber, whether it is a random orientation or it is a uniform orientation or it is orientation at an angle of 30°, 60°, 90°. This also plays a crucial role in your deciding composite materials. So now the researchers' ultimate focus is towards this one, because when we have some lagna or some defect in the fabrication itself, that will directly influence our final properties. That has a direct relation. So we have to be very, very cautious during the fabrication stage in terms of deciding this fiber weight percentage, fiber length, the fiber orientation angle. Similar to that, we can vary the matrix weight percentage also, but the matrix has no length or no orientation because it is a semi liquid like structure. So we can't define only the weight percentage. So that you can vary, and you can now introduce some interesting fillers also, and with that fillers also you can add in different weight percentage, 10, 12, the examples I am saying. So this one have a huge influence on your mechanical final performance of your composites. That includes the mechanical property also. Okay, so this is the few small introduction. Let me take the pointer. Okay, yeah. So as I pointed out, the reinforcing fibers which are reinforced, that is renewable, and it may derive from plants, and some fibers in the earlier stage they derive from wood also, and it is a combination of two or more materials. The first material is the matrix, the next material is the reinforcement, as I pointed out to you. Now our machine learning will give a clear picture about this weight percentage, and accordingly how the performance will affect. That is the key thing I would like to highlight here along with the introduction point itself. Now let us quickly see how the composites are derived. So there are various types. The first one, MMC, which is none other than metal matrix composite. The second one is the polymer matrix composites, PMC. The third one is the ceramic matrix composites, CMC is there, and this three is based on the uh, matrices. Please note these two will be based on the matrices. See, that's why the matrix term is involved here. The polymer family, you can use a polymer family composites. Okay, like that. Then metal matrix, you can use the matrix as different metals derived from various sources. Then this is the ultimate need of the hour, the ceramic, which has high heat resistant capability. But the difficulty in the ceramic matrix is the challenge in the fabrication of the composites. Even though researchers overcome that, and still quality research is going on using the ceramic as the matrix, which is ultimately the strongest one and has the capability for high heat resistance. Okay. On the other hand, our team focuses on this one. So we are all more familiarized and expertise about the behavior of polymer composites. We worked on using different polymers such as unsaturated polyester. Epoxy is the strongest one, which has high density. Then we have vinyl ester. Apart from this, we have some quality biopolymers out there like polypropylene, PLA, polylactic acid. All these things comes under the biopolymers in such a way that we are able to generate a good biodegradable materials. So focusing on the biodegradability concept, we have to go for using those kind of biopolymers. And most of the biopolymers, they undergone some chemical processing and readily available in the market. Since basically we belongs to mechanical expertise, we don't go for deriving our own polymers by adding various composition. Okay, normally chemists are doing that one. That is, they are expertise towards that one. Then the next category, as I pointed out you, is based on the reinforcement geometry. How the reinforcement you are going to use, how the geometry will be based on that. The first classification is particle reinforced composite. So my research team, my research lab focus on 2 and 1, these combinations. Let me tell you clear in my coming slides. Okay. And what is this particle reinforced composites? Here you are going to add in the form of particles which is of micro size. Okay, nano composite is a tiny, I mean it's a separate story, very big story. Okay, the nano composites. So here the particle size of course should be of limited to micron size only. Then as I told you few minutes back, the fiber reinforced composites is the one which is creating a lot of attractions till date in the modern days, since it has a huge advantage of producing a fully biodegradable material which possesses lightweight, which possesses excellent strength, and of course the most important thing, it is of low cost. Sometimes it is available for free also. Okay, so that's the thing, the second one. Then the third one is the hybrid composites. As you all familiar about the word, the terminology hybrid. Okay, that is the hybridization. You are going to combine now one or two fibers, one or two materials, or you are going to combine the fiber with a metal in such a way that you are going to produce a fiber laminate. So all these things, all these items comes under the hybridization concept, the hybrid composites. Okay. Then the next focus of this lecture session is about the mechanical properties. As a specialized person, we are going to focus on the mechanical performance of these natural fiber based composites. So the mechanical characteristics, what it refers to this, it focuses on the various properties and how the developed composite materials is going to react towards this property in such a way that under the mechanical characteristics and under the mechanical characteristics, the four properties that as researchers we are strongly focusing on is the tensile strength, the flexural strength, the impact strength, and followed by the hardness is there. Let me explain one by one. What is the tensile strength? The tensile strength is none other than the ability of my composite material to withstand the pulling force, to withstand the pulling load. So here I am going to subject my developed composite material uh, to this tensile studies, and I am going to discuss how it performs when the load is applied, especially the pulling load. Pulling load in the sense how we are going to test the specimen is one end of the specimen is tightly folded in the grip, and another end of the specimen is attached with the top load transducer, and now the load is applying. The force is applying the pulling force, it is going to elongate. At one point the fracture will happen, and the results were stimulated in the software, from which we are able to understand how much strength that particular composites able to resist, and that values we usually refer it in terms of megapascal, 30 megapascal, 40 megapascal, like that. Now let us move to the second one. The tensile strength is, as I told, pulling load. The only difference here is the flexural strength. And here the pushing comes into picture. That is the ability of the material to resist the pushing load. Now now I keep one end of my material like this, and over my material through the top end I am going to apply the force, compression, pushing force. Okay. Oh, sorry. That one. Just a small correction. That one is the compression force. Now the flexural, what I am going to do is I am going to carry out a 3-point bending testing in such a way that I will keep my specimen like this. Just a minute. I will use the pen to draw. Yeah. So this is my specimen, and in my specimen at the center I am going to apply the load, and these two ends are fixed. These two ends are fixed here. So that is said to be as the flexural load, where it indicates the 3-point bending test. This is the one. So how much pulling load? Later on your specimen is subjected to a bending, and at one point the fracture will happen. Okay. So that is said to be as your flexural strength. Okay, the second one. Then the third one, the impact strength. Impact strength can be done by using two methods, Sharpie method or ISOD method. Only the direction position is changing, where you are going to keep your specimen either like this or like this. That is the two method, ISOD and Sharpie. Now an impact hammer is going to come and crush your specimen, hit your specimen. The impact hammer is going to come and hit your specimen like this. Okay. So how much energy your material is able to absorb? That is the ability of the material to absorb the energy is said to be as the impact strength. Okay, so this one is applied by means of a hammer. The force is applied by using a hammer exclusively. So that is said to be as the impact analysis. Okay, how much energy your material is able to absorb, and it is represented in terms of joules. Since we are talking about the energy absorption, it is in terms of joules. Then the harness, we can normally go for the Stordy harness, where by using a Stordy harness tester, I am going to keep the tester over my specimens like this, okay, at different points like this, and the harness tester will shows the value. I am going to press over the specimen surface in such a way that the indenter attached with the harness tester will measure the surface roughness. Will measure how hard the surface is. Surface roughness is different tester. So how hard the surface is, it will give you, it will show you the value. So that way the use your harness. Here it is a unitless one. We are going to give it in value, example 10, 15, 20, like that. And all this testing, we are going to focus on the prepared composites, and this testing results, in order to ensure the perfect correct value, we are going to take average of 5 specimens. For example, tensile strength for the same combination, 20% weight fiber, I am going to take 5 tests, 5 samples and 5 testings. Now I have 5 values in my hand. That 5 values I am going to add, and the average is my final results, in such a way that we are able to ensure the quality result. So this is our ultimate focus. So now I am going to discuss with you in the topic how the machine learning will help to analyze these properties. Along with that, other few properties is there. In fact, we'll discuss, and in between I slightly introduce the term which creates a small charge, that is compressive strength. The compressive strength is also another one, and we have like that erosion strength, wear strength. These are also coming under the mechanical properties, but our key focus will be towards on these four only initially. But apart from this, we done the studies on the erosion also. So in my coming slides, I am going to discuss with the results, how we are getting interesting results, based on which you are able to take forward. You are going to utilize the different machine learning algorithms approaches available for your work. Okay, so now let me move on to the further introduction. Yeah. That is about the fiber filled composites. As I told, this one I don't, I would like to quickly skip, because already I talked a lot about this. The different natural fibers, carbon we can use. Glass is not a natural fiber. Please differentiate this one. Here they commonly mention all the type of fiber. Glass is completely obtained by means of chemical processing, which is of very high strength. But this will be replaced nowadays by natural fiber like carbon. Carbon has a strength equal to glass fiber. Glass fiber has number of issues in their disposal that cause some environmental issues. And the natural fiber, this is what I told, when you climb natural fibers, which has purely dependent on the cellulose content that it has. And we can use these composites, focusing on which type of industry is very important to know. So household, structural, aerospace, automotive, construction, and sporting goods are there. Sporting goods, many of the items are nowadays replaced by the natural fiber composite. In fact, our lab team members tried one small mini skating board for the kids, and it came in a very fine shape. But unfortunately, the resistance after a specified time period, it got fractured. So we are not, we will face some challenge to make it as a commercialized one. And also at the time I don't get any enough good industrial support. That is also the challenges. Okay. And as I told, the traditional characterization methods, what researchers are always focusing on is doing the experimental studies of tensile, flexural, and impact. Then they just take the failure portion and subject the failure portion to scanning electron microscope studies, through which they are able to understand the microstructure, and followed by that they are able to understand the performance of mechanical properties, as I told. Okay. Now, the present day, the industry's major focus is to minimize the non-renewable resource procedure and adopt eco-friendly materials by waste use, waste recycle. And the industries are in a high desperate need of focusing towards minimizing the material waste, because all of us know that this material waste will be a very big challenge in terms of financial wise. So we have to be very careful, and the current industry requirement is these things. Now, for this, the polymer and natural fiber composites, they are going to be the ideal material. They are going to be the right choice. Why? Because they address the reusability, they address the recyclability, and they tick the box of long-term constancy and widespread accessibility with a very reasonable cost. So these tick marks, these check boxes, these checklists will all get ticked by means of your polymer with natural fiber composites. That makes it as a ultimate greatest of all time till now. till today. Even though lakhs and lakhs papers, researchers published all those things, still the thirst for this combination is there in such a way that like the day by day new app, new technology is coming. We are in a desperate need of new material with some interesting performance. So to satisfy those needs, we have this combination to exist for another decade also. Who knows? Yeah. Then let us move to the key discussion. So right now I discussed you broadly about the composites and the different types, and our focus is on the natural fiber and polymer composites, as well as the property focus is on the mechanical performance like tensile, flexural, impact and hardness. Now, how to analyze this one? So for that, we are in need of, I mean, how to analyze using the machine learning approach. First of all, I will give you a brief hint about background about the machine learning approach. So what is this approach is, this approach, under this, it's a huge umbrella under which number of sub-techniques is there. Okay, so we are going to use different techniques from which I am able to understand which composite combination is the best one, which combination I am able to understand. So for understanding this, first whatever the algorithm, whatever the technique under the machine learning approach I am going to choose, I have to train it with my requirement. If I directly feed, okay, it is not like our calculator. If you put 4 into multiply by 6 and press the equal to means it don't give 24. It's not like that. First you have to train with your data sets. Then you make the algorithm to understand this is my expectation, this is my input, and this is the expectation from you. That is the output. Like that we have to train the system. So for the training we are in desperate need of quality data sets. So data sets is the very crucial thing, and in fact while performing our research we face a lot of challenges regarding these data sets only. How to use a quality data sets, how to use it in a more ethical manner. Okay, because nowadays you are all more familiar of how the journals are asking what are all the requirements we have to give, proper approval, proper data sets. In fact, that will be the need of the hour due to the AI, because of the AI usage. Okay, so here the composite materials data, you are able to extract with the proper permissions through the mat web, where we are able to get thousands of different materials properties, including your natural fiber based composites, which is our ultimate focus. Then of course the scenario which is very popular nowadays, almost all the channels are turning towards the open access in such a way that the research will be easily available to the young researchers. And you are all more familiar, of course many of you are using this one or about to use. ResearchGate is there, Academia Edu is there, Scopus is there, Google Scholar is there. Okay, and through by means of more number of open access, gold open access channels, you are able to get the full paper through the channel portal itself. Okay, from which you are able to get the data sets. That data sets is also with the proper permission. If you want to use other data, the data will be provided by other researchers. All happens in a more ethical manner. That is very important. And for performing these machine learning approaches, some key papers that I would like to uh, present you. I don't take much time on this. Just quickly I will throw some inputs. Okay, later on you can also refer better. You can refer some better papers also. In my work line, this earlier published research is very much matched. So the first one is about the prediction of macroscopic mechanical properties and microscopic cracks. See here the machine learning approach they used is the DNN method, that is coming under your machine learning as a regression model method, and they compare it with the RVA method, and we also used this RVA. Later on I will show you my results how we obtain. Okay, so here they are focusing on the cracks, I mean failure aspects, but purely the mechanical property. Likewise, in 2023, in the year, another one key paper published using the natural fiber reinforced plastic composite. Very interesting. And here they use the technique deep multi-layer perceptron technique. Interesting technique. Okay, under your machine learning upper law. So here the MLM, that is the multi-layer perception. Okay, MLP, sorry, MLP, multi-layer perception. It's used to measure the various parameters as we discussed, the tensile, flexural, Young's modulus. Young's modulus and elastic modulus derived from your flexural and tensile studies itself. Of course, they are closely related to one another. And you see the improvement in the percentage they have mentioned around 87.2 like that, which is quite interesting. That attracts us towards our research to use some quality machine learning approach. And in another paper published in the year 2022, where they used the ANN. Please note ANN also comes under your machine learning approach. Okay, that is BPNN, SNN, ANN. I mean artificial neural network. Here also they predict the mechanical performance for the green compost, green fibers. This is what I had mentioned as the biocomposites, where they used this type of green fibers but for better composite manufacturing. And they are used two types of methods, BPNN, SNN method, and three mechanical properties contents they focus. And you see the results of accuracy in the sense, one of the most important thing of the machine learning approach is you are able to compare your experimental results and how much your experimental and the results derived through the machine learning approaches. That is the accuracy compare. So here the accuracy is very good, 96% is there. Then in 2020, based on the polymer composites, how the machine learning is application. So I am only very new, but I am late. Right now I am focusing. But you see, earlier researchers they start hardly 5 years back, half a decade back itself, they started using the machine learning approach for polymer based composites. So they used the different algorithms focusing on moisture saturation level, and they also understand a good accuracy. Then the next one is based on the basalt fiber. Here they use SVR method, all those things. Then another one is for the bamboo fiber reinforced and palm oil based resin, like that. They use along with machine learning the finite element method also, through which they are able to compare the experimental results with the theoretical ones. And the next one is the another unconventional approach, and using the CNN approach, the convolutional neural network. That is another interesting one that also improve the accuracy, gives some good efficiency from the results we are able to understand. Then another one published in 2024 focusing on the machining aspects. That is also very important when we focus on developing innovative product, where the machining also be a part. So that also to understand from the literature. Now the next interesting thing is, what are all the gaps that we are able to understand based on this, based on the literatures that we come across. That is, the lack of real-time analysis is very much missing out in the case of natural fiber composites. Okay, and this one will be done by means of your machine learning algorithm. So from the uh, literature in the sense purely with natural fiber mechanical performance alone, and with natural fiber mechanical performance and the machine learning approach, this set of literature. So that, from that we are able to understand the machine learning approach performance. And the lack of standardized data, there is no standard way to collect composite material data from working people. This is what I told you, the challenge what we face is getting a more number of data. Okay, that is the challenge. And how we are motivated, what motivation makes us to start doing this one, that is the involving the machine learning approach in the natural fiber composites. The first one is the high specific strength. As I told you many times earlier itself, the composite material possesses a better strength when compared to relative density. So this makes them suitable for lightweight applications where the strength is critical. Then the second one that makes the natural fiber based composites more interesting is the cost effectiveness. When compared to synthetic alternatives, as I told, glass fiber is the very strongest one. The composite developed from glass fiber, but the glass fiber is the coming under the synthetic. So now the synthetic alternatives in the sense in terms of the strength also equal to your synthetics. Okay, and comparing the overall life of the composite material. So this makes the natural fiber composites more attractive. That includes consumer goods and construction. Yes, of course, I would like to highlight here in the construction sector nowadays more natural fibers are used to improve the quality of the structure, wall structures. And in fact people started building houses using completely polymers. Then of course the another big sector is the automotive industries where we are using the composite materials. And this is the objective towards our research to predict the mechanical properties using a supervised machine learning. Different techniques we adopt, and from the literature only. As a mechanical background person, I don't right now able to develop my own algorithm. So as I told, I am in the preliminary stage also. Our research is the fundamental one. So by taking the algorithm from the literature, I am going to apply the mechanical performance analysis. Then, by using the SEM images, we are going to carry out the unsupervised machine learning, and we are also going to carry out the deep learning analysis. And I am going to focus on the first one. Remaining two, based on the uh, time, let me try to cover up. But for this, I am having complete case studies. This remaining two, due to the time consumption, and also we are doing further research focusing on this. I don't have enough results at this juncture, so I will focus on the first one. Yeah. So let me move on to the case study one. So the case study one, what we did is we gathered the data of different natural fibers. And for your kind information, since I am working more than a decade on the natural fiber, right now I don't take any data from the available data sets or the online source. It is our pure original data, okay, that we take for the different natural fibers, which we done some research already, jute, hemp and flax, along with different polymer matrices, as I told, epoxy, polyester, polypropylene. Okay, and that data mainly focus on the tensile strength, flexural, all those things. Now, after make ourselves, ensures ourselves that the data sets is ready, and what properties we are going to focus. We are going to focus on the four properties. Then we have to decide which type of machine learning approach that we are going to choose. So we are going to choose the SVM approach. Okay, and decision tree for the classification, for the different classification of various properties, from which we are able to obtain a better one. Okay, and from this, what is the outcome we are going to expect and we are going to get is the natural fiber based composite material rate and its a mean average expected, and finally the uh, accuracy. Okay, the MAE value and how much accurate the produced results, that also we are able to conclude by means of using this algorithm. And this is the block diagram as I showed. The polymer composites using different natural fiber and polymer based composites, and the mechanical properties we focus on is the tensile strength, flexural strength, and impact strength. And all these things characterization was done, and we have the data sets. So the input data of different property parameters such as tensile, flexural, and impact strength is given. Then we are going to carry out the machine learning approach analysis using the SVM method, SVM or distributor, then evaluate the different composites and compare with the accuracy. Okay, and the material properties in the case study 1, let me tell what combination we have used is, we don't use the natural fiber. Up to my previous slide I generally focused on that one. Now from this slide I am going to talk focus towards the key results that we got. So now the combination I am taking is the biochar, which is derived from the various waste. What are the waste is, the first waste is called as the cashew nut cells. We are all taking the cashew as snacks or now for good for cooking purposes. Now for that cashew is taken from the cover as a seed, and that will be utilized for different cooking food purposes. The remaining outer cover is thrown as the waste. Now I am going to take that waste that is called as the cashew nut cells, and I am going to subject it under the pyrolysis process. I am going to heat it in the absence of oxygen for a temperature of around 500 degrees Celsius, and at this juncture it creates the biochar, which has excellent properties in such a way that the biochar has possesses good mechanical properties that makes it ultimately a good alternate for the existing materials. Like cashew nut cell, we can focus on the sugar cane waste as well as the PET waste, that is the plastic bottle waste. From all these three, we derived the biochar of different types, and those biochar is reinforced with the polymer matrix, and the composites were prepared, and the prepared composites were subjected to the tensile strength, the impact strength, second one, and the third one here we focus on the erosion resistant properties, how much the composites is able to withstand the eroded, how much it has the capability. Okay, so that is the material property we are going to focus for the prepared biochar filled composites. So the biochar is prepared from these three waste as I showed. Okay, and the matrix is the polymer one. Now the data set is ready for all these properties, erosion, tensile, and impact. I have the values. I did my experimental results and experimental runs over. I have my experimental values as the data sets to feed the machine learning model. And the machine learning model here we are going to use is focusing on the ANN and other predictive algorithm in such a way that we are able to predict the material properties. Okay, and the experimental methodologies that used is we are going to process the pre-buck, that is the biochar with polymer polymers, and we are going to validate the tensile impact strength of the composites. Now, this table shows the interesting data, okay, that I showed, which we used for training. Okay, so training, sorry, now for the different types of biochar mentioned here, cashew, pet, and sugar cane. As I told you, the composites are prepared of three different ways: 5, 10, 15. Now, this 5, 10, 15 values I am going to provide as a training data 18. From that, which 12 data are subjected to testing, and out of which 5 are validated. Likewise, for the next combination, for the third combination, the different preliminary stage of training, testing, and validation will be done. From this, now what I am going to obtain is, I am going to obtain the hidden combinations. For example, this combination cashew, I told 5, 10, 15% values I am having from the experimental result. Now what is the 6%? What is the 7% value? How much? 8, 9, 10, like that. Like that, we are able to understand the different weight percentages using the uh, your what I mean machine learning approach. That is the very big advantage of machine learning approach. So we are able to understand the hidden combination that offers some that possess some interesting properties, good properties, enhanced values also. Okay. So as I told, the data set as I shown in the previous table, training, variation testing, and validation set sizes are given. And here we have the larger training data for cashew composites that provide extensive valuation, and consistent validation set sizes, 5 for all. This should be maintained uniform in order to ensure the results we got should not create any kind of confusions like that based on that. So it reduces the bias and enhancing the generalizability. Okay. Then this is the interesting results that we got through the machine learning approach. I mean through the uh, experimental studies. That is for the first property, erosion. Please note this graph shows the result that we got. I mean the erosion resistant. Okay, so here you see the graph is plotted against impingement angle in the x-axis versus the erosion rate. So when you compare neat is none other than it is purely the polymer matrix alone. Now the first is polymer with pet char is the composite. Second one is the cashew waste with polymer uh, composite. Third one is the sugarcane char, sugarcane with the polymer waste, polymer matrix. I'm sorry. So you see when compared to the neat, this is the graph for the neat. When the impingement angle increases from 30, 40, 30, 40, 60 up to 90, you see there is a slight decrease in the erosion rate in the case of pure polymer. In the case of other type of developed composites, the better resistance is provided at 45 degree. Then there is a drip in all the three cases in 60 degree. Followed by that, when the angle goes on increasing, the trend is going to decrease drastically. That is, it possesses a good erosion resistance. Okay, that now we introduce this erosion into the machine learning approach, and we find the RCV, that is the relative contribution value, and I1, I2, I3, I4, I4, I are the 5 different inputs given for the 3 set of composites, cashew, pet, sugarcane, and these are all the different relative value that we obtain, which is considerably quietly good, less than 0.5. It should be within 1. So this study, the relative contribution shows From that, what we are able to understand is that I2 and I3 are the most influence variable in the case of all the three composites. Okay, whereas the variable I4, I5, they exhibit least impact. That means that their prediction is lower. Their prediction is not good. Okay, and optimizing the high impact variables I2, I3 can improve the efficiency and accuracy of our predictive model. This is what I told. We are able to get the better optimized combinations. Okay, I1, I2, I3, it indicates the different weight percentage as I am talking with you from the beginning itself. Okay, then the ANN model evaluation is comes into picture for the Casio based composite data that creates a strong correlation, which means that they are highly effective in predicting the erosion rate based on the provided input parameters. Okay. On the other hand, the second composites, the PET-based composites model, they shows a same strong correlation, but when compared to the first one, Casio, it is little low. And here also the suggested input properties are well aligned with your prediction. Then the third one is the sugarcane based, where it has the lowest CC among the three materials. That is the correlation. Okay, this indicates that there should be some more variations between the training, validation, and texting, or due to the creation of noise that happened during the input-output processing and the input-output relation also. That we have to check it out. Okay. Then this is the evaluation table, the different architecture combination for the three set of materials that we are using, Cassiopeia sugar with the architecture IHO 571, and the correlation coefficient percentage is obtained and presented here, where as I pointed out in the previous slide discussion, the third property faces the lowest CC, correlation coefficient of 80 percentage only when compared to other three. Now that first case is over. Now the second case, what I pointed out is carrying out the unsupervised learning. This unsupervised learning I am going to not discuss with many pictures and results. I am going to just give you the overview. As I pointed out, I am going to focus more on the first objective as I pointed out. So here the unsupervised learning is exclusively involved for analyzing the SEM images of natural biobiotic composite materials without requiring the label data. And we are going to normalize that one, adjust the pixel intensity values to a common scale. Then we are going to done the noise reset because this affects your input output relation. As we came across in the previous results and discussion, we noticed for the third type sugar can, the CZ value is very low, which is exclusively due to your what's that one, that is the input output correlation. So we have to carefully uh, notice all these things. The noise reduction is that, then we have to carry out the image segmentation using the image segmentation values to isolate which region the failure occur, which regions that gives better results, like that voids. There is also the one factor that leads to failure. Okay. Then evaluating the cluster results and visualize the clusters. Cluster validation is also a very important one, using various techniques like Silent score, Davis Boolean index, all those things. This one we have to yet to start and have a good results. Then plot the clusters in 2D or 3D space. For this we use techniques such as TSNA or PCA. Then the last one, deep learning approach, we can go for applying over our SEM images, the largest data set of SEM image that we are having in our hand for the different composite materials. And here we have to ensure that the training should be done in a proper way, and we have to ensure all the label will be given a all the image will be given a proper label in terms of defining their material type, defining the defect present, and all those things in such a way that in the training the machine learning approach will understand, interpret, and give you the correct output results. Then you have to do the pre-processing. The pre-processing stage involves the resizing, normalization, and augmentation that includes flipping, rotation, etc. to increase the diversity of the data set. Then the next stage is splitting the data. You are going to divide the data sets into training and validations and test sets, typically in the ratio of 70-20 is to 10 or 80 is to 10 is to 10. That is the recommended ratios to get a better optimized results. Then for performing the deep learning analysis on the some images, you can use either a CNN model or a RNN model, where we have to train the models using the augmented data to classify which composite material patterns that we are going to analyze, and to identify the challenges, anomalies also. And the training deep learning model is evaluated based on a real world data sets of composite materials in such a way that we are able to compare and assess the performance in terms of accuracy, precision, robustness, etc., to noise, artifacts, etc. And this is the continuation of the study too. We are going to use the artificial neural network and the I mean SVM method. Okay, this one I will skip. I will move to the because there is some repetition in the slides. I'm sorry for that. So that's why I skipped. And now let us move to the discussion on this particular one, that is the data collection. How the data collections, the testings will be done based on the American Society for Testing Methods, and we have the experimental results. From the experimental results, as I told, the data sets are fed into the training. Then advanced data pre-processing, where it helps the data sets to be pure, which does not affect the outcome. Okay, and model training also is done by using the linear regression method. Okay, by trained the mechanical properties are trained. Then optimization of the model also done, that is the model validation was done fine-tuned by using cross validation, regularization, and hyper parameter tuning also done in such a way that we are able to ensure we are getting a high quality accurate results. Okay, that is the very important thing. Then the prediction phase, the trained model is going to now predicting the mechanical property values for composition between 1% and 16%. This is what I told. The percentage we used for the experimental results is varied between 5, 10, and 15. Not continuous. 5%, 10%, and 15%. These three only we are giving to the training. Now we are able to find the collection of percentage varying from 1% to 16%. That completes that we are able to analyze. Okay, and the model performance was analyzed using MAE, SAE, and R square metrics. All the results in the coming slides I am having to ensure the prediction reliability. And this is the final stage in the methodology, where you are going to interpret the results. The actual results done by means of experimentation is compared with the predicted values to evaluate the accuracy and identify the best performing property. So this is a small back diagram that shows the complete methodology, the data collection, data pre-processing is there, prediction and the evaluation. This includes the comparison of the both results. And in the data pre-processing, the very important stage is the model training and the model optimization. Then only we will enter into the prediction stage. And we have the table that gives the values, the intermediate values from 1% to 16%, where the no actual data is available for large number of variation. As I told, we have the actual data for 5, 10, 15 percentage only. Now the other, in between all the hidden weight percentages, we are able to find and we are able to understand that the predicted values closely match the experimental ones and proving the model precision. So the model reliability is further supported by means of getting a smooth pattern and by means of getting a critical composition level. And this is the complete results. Quickly, I will tell a few cases. For example, this 1, 2, 3, 4, 5, where we don't have the experimental results available. Okay, the value I had in my hand by using the experimental results is first 0, 30%. So through the machine learning, the predicted value is very much closer, 31, and 5% is there, 47.92, and here you see there is a decrease in the predicted value. 10% is our original value, which is very closer. And in our case, we obtained good results through the experimental studies is the 10% only. And 15%, see this interesting one, the same thing. From the experimental 41, from the predicted value through the machine learning approach also we got the 41. And in between now, take 0 and 5, in between 1, 2, 3, 4, we don't have the experimental results, but interestingly by means of the machine learning approach, I am able to predict how the values will be in such a way that I am able to understand any good combination is hidden, is available like that. Okay, see here, there's 161, 66 is there, but in between I am able to understand a very high value, 75 is there up to. So that is the beauty of this machine learning approach in applying in the composites to understand the predicted value and to make ourselves get a fine optimized results. And these are the mechanical properties that comparing the actual and the predicted value. So what you notice from this graph, if you see the graphs, almost all the 4 graphs, there is a perfect with a slight deviation. If you take the tensile strength, in the tensile strength from the actual, the predicted value is slightly deviated. The predicted value is like a straight line. It follows a straight pattern like this. In the same way for flexural, interestingly, the mapping is almost happened, almost done here also for the impact, the predicted and the actual value. There is a slight variation in the harness, our last focus. And our ultimate aim is to find this statistical parameter value, the mean average evaluation, mean standard, as I told you in the earlier slides, and the R square value. And this shows how much our experimental results is actual results is very much close with the predicted one, and how much perfect the experimental work is done. That also we are able to ultimately successfully present by means of the machine learning approach analysis. So here you see it is 1.42, it is 3.6, it is the other values are closely gooder, and this is the R square value, which is which should be always 1. So if we take all the cases, the 1 is the 1 indicates the better results, better prediction of the theoretical with the actual ones. And this is the evaluation metrics showing your 3 values, MAE, MSC, or I mean the same thing only. I'm sorry for that. It is the graph based on the previous data only. It is just a repetition. And now the evaluation of mechanical properties is done with all the R square values have values closer to 1, that indicates the high reliability. This is what I told. And tensile strength shows higher error. This is the drawback which we noticed, but remains the acceptable limit. It don't go beyond the acceptable limit. Then we have to take a deep further discussions on this. So that will be not that is the case not happen. And overall, the model we used is robust and consistent in predicting all the mechanical properties of natural fiber composites, the SVM and the another one. Yeah, both will be very very good. And let me move on to the last slides. With this much more than 1 hour, I discussed the fundamental usage of machine learning approach in different natural fiber composites. Let me conclude with the applications. How the deep learning approach is also more effectively used in the composite sheets for optimization. What kind of optimization is? The optimization in the sense of composite layout, as I pointed out to you, the different weight percentage. Then the micro scale structures. This focuses on your composites particle size, your composites fiber length, like that, those things. Then phase distribution geometry. The geometry includes the fiber orientation, the different angles, and the phase distribution. It is a random one. You are going to use a short fiber or you are going to use a long fiber. So all these critical parameters that completely affect the performance of the composites is optimized by using the deep learning approach in a more appropriate manner. Then the property prediction is also another excellent application of deep learning in composites. Property prediction in the sense of, just I pointed out to you so past 1 hour, that is the tensile, flexural, impact and hardness, like that, component fraction, acoustic signal. These are all additional advanced properties that is the need of the hour. The thermal conductivity, spectrum information, microscope, volume element, which are all some advanced progress, advanced results that focuses on major industrial applications. So these things also we are able to done effectively by using the deep learning approach in composites. And the data processing that focuses on the failure mechanism of the composites, mainly the crack progress, crack detection, how the crack is, and then phase segmentation, what are all the different phase, failure phase, or it is a better result phase, then formation of void detection and 3D reconstruction in the case of buildings, all those things, because we are most widely used using composite materials nowadays for the construction application. So these are all the broad areas applications of deep learning in our day-to-day composites activity. So with this, let me happy to conclude my presentation, and more welcome to expect your questions, as I also started my fundamental research towards the usage of machine learning approaches. It will be a very very effective tool that everyone can use, start using, and dip deep into that one in such a way that you are able to get some quite interesting results. So with this, let me conclude my presentation. Hope if you have any questions, you can share. I am more welcome to reply your queries. And thank you for your patient listening for more than an hour. Thank you once again. See you. Bye.